You are the host.
Recording in progress.
Madam, you are now in host.
Okay. I hope the screen is visible.
Yes, ma'am. Screen is visible. Good evening, ma'am.
Yeah, good evening. Yes, welcome everyone to our data science class, day 2. Day 1 was just a brief class of half an hour that I took, and I gave an overview of what data science is and the basic skills that are expected from a data scientist. So today let us have a discussion over statistics. Let's start with the statistics portion first. So like as I told in the last class, when we talk of statistics, we basically talk of two different types of statistics in data science, in general statistics as well. The first one is, if you could remember, it is descriptive statistics, and the other one is inferential statistics. Before going into descriptive and inferential statistics, there are a few terminologies that you need to be aware of. Those two will be, first one is population, and the other one is sample. So population will be the main data, no? Your main data population. When I speak of population, means we're actually speaking about data only, the main data collection, and the sample will be a subset of this data, meaning to say subset of the population. Now the question arises, when we have this main data set which we call population, why do we need to define another subset of it which we call sample? The main reason being, usually our data set is huge. It will contain millions and millions of data, and processing upon such millions of data will be little difficult, time consuming as well. So what statistician or data scientist or any machine learning enthusiast will do is, he or she will take a sample of this population. And the condition is that that sample should be a good representative of the population. The sample should be able to represent the population faithfully. Now for that also there are certain criterion that we will discuss as to how to take samples from a population that would make it meaningful. But for the time being, you can remember these two terms. Now when we talk about population and sample, another two terms come into picture. Related to these, those will be called, related to population are parameters. We define population using parameters. Parameters are those statistical quantities that will define the population, that describes the population. And whatever the statistics that we calculate, whatever the numerical quantities or numerical descriptors we calculate for the samples from this population, those will be called statistics or estimates. Different fields will have different names. Like suppose you have a population and you need to define its mean. So normally, mean for a population is denoted as mu. Might be known to you, but when we talk about samples, we define the mean of the sample to be x bar, something like this. So these are few differences, few terminologies, few things that you need to keep in mind. So let's start with this descriptive statistics. And the reason behind stressing much upon the statistics is that, just keep in mind, it is one of the essential subject matter of data science, and a data scientist is expected to have a deeper understanding of the majority of the statistics portion. So first we will try to cover the descriptive part of it. So when we say descriptive statistics, so we will be talking about some measures of central tendency. These are proper statistical terms. Some measures of dispersion. These terms might be known to you. For those for whom these terms are known, means this will act as a refresher. So just to go through measures of dispersion. We will be talking about measures of location as well. These are few important measures that will come under descriptive statistics. So when we talk about measures of central tendency, we talk about a single quantity that acts as a description of the population, like mean, median, mode, the most well-known, most commonly used and the most well-known measures of central tendency, mean, median, and mode. And I hope you all might be remembering how to calculate these mean, median, and mode. So when we talk about mean, means we are talking about the average, average of the data that we have in our sample or the population. Now, when I talk about descriptive statistics, means I'm actually talking about population, but these statistics or these quantities can be calculated for samples as well. So in general, mean means a number that describes the average value. The second measure of central tendency is median. And median refers to the middle value. The middle value. And mode is third measure of central tendency, and that refers to the data that occurs most frequently, meaning the data with the maximum frequency, most frequently occurring data, or most frequently occurring number in the data, you can say. So mean, median, and mode, these are three major measures of central tendency. Let us look at one special characteristic, not just characteristic, one important note. We can consider it as a note. Suppose I have this data, 1, 1, 2, 3, 5. Let us make it simple. What is its mean? How do you find mean, the average? It's simple, right? You will just sum of them all and divide by the number of observations. It is 5, 3, 8, 9, 10, 11, 12. So the sum is 12 and we have 1, 2, 3, 4, 5 observations. So that makes it 2.4, the mean. Let's check out its median. When we talk about median means, we are searching for the middle value of the data. Now, when you need to find out the middle value, the first thing is to sort out the data. Now, in our case, the data is already sorted from smallest to the largest. So the only thing you need to do is you just have to search for the middle value. So since we have odd number of values, the central one will be your median, right? So it's 2. And mode. Mode is the most, the one with the maximum frequency, the maximum number of occurrences. So 1 occurs twice here, 2, 3, and 5 all occurs once only. So 1 has the maximum frequency, so the mode value will be 1. So one thing to note is mean and median are majorly used for numerical data, and mode is used for categorical data. Numerical, categorical. So one thing you can note here is, suppose now this data, suppose I make a small change in here. Like suppose I had this data 1, 1, 2, 3, and 5. Suppose a new data comes in, make it 20, suppose. Let's check out what are the new mean, median, and mode values. The new mean will be, now it will become 25, 8, 9, 10, 32, divided by, increased by 1, right? So this becomes 6. So the new mean will become 6, 5, 30, 6, 3, 18, 5.3 something, right? What will be the median value? Median means the middle one, right? So here now, since the number of data or the number of items in this list is even, so we will have 2 middle values, right? 2 and 3. So how do you calculate the median? We just take out the average of these two. So 3 plus 2 is 5, divided by 2 will become 2.5. So the median value is 2.5. And the mode still remains the same. 2, 3, 5, and 20 occurs once, while 1 occurs twice. So the mode is still 1. Now, why this example is worth noticeable means we have introduced a number which looks quite different from the other numbers in the list, right? 1, 1, 2, 3, and 5. They are closer. 20 is little farther from these numbers. Looks like some peculiar type of number may be out of this category. Such numbers which looks quite different from other samples are called outliers. So 20 here will be considered outlier. So when your data suffers from the presence of outliers, which measure of central tendency might be better for you? It can be seen from this example. So earlier the mean value of the list was 2.4. Now, when the data changes in this way, meaning when outlier comes into the data, the mean becomes 5.3. Mean earlier it was 2.4, now it is 5.3. Median was earlier 2, now it has become 2.5. And mode is still 1. Meaning to say, mean is the most suffered measure of central tendency when outliers are considered. Okay, so most of the time you might look at data scientists having faith on median much than the mean, since median values are not much affected by the presence of outliers. So this point you can keep in mind. So mean, median, mode, these three are major measures of central tendency. The next we have measure of dispersion. When we say dispersion means we are actually talking about the numerical quantities that will give you idea about how much the data are spread with respect to the mean. So measures of dispersion. This is another descriptive statistics question. Measures of dispersion. So one common measure of dispersion you might have seen heard is variance. So variance is actually, variance takes into account the distance of data from the mean, right? In a way. If we need to symbolize it, how do we symbolize it? It is usually written as sigma square, right? In books you might have seen. And how do you calculate variance? It is actually sum of all these differences, right? Sum for all I, xi minus mu whole square divided by n. So you calculate the distance of that data, meaning the items in your list, items or samples in your huge data from the mean. Mu is the mean. So how far is your data from the mean? You square it, do it for all the samples, sum it up and divide by the number of observations. This is how you get the variance. It will give you idea about how much spreaded the data is. The larger the value of variance, the more spreaded the data is. Suppose you have some data sample. The scatter plot looks like this. And you have another data set whose scatter plot looks like this. This will be supposed to have larger variance, right? Mean will be somewhere here, and the data are much spread away. And here, mean will be somewhere here, and all the data are close by, or the numbers or the values, they are close by. So that is how it gives the idea about the spread of the data. Hence, it is called the measure of dispersion, how dispersed the data are. Now, related to this variance is standard deviation. Standard deviation is nothing but it is square root of variance. Okay, can anybody tell if we already had variance term that gives us the idea of about the dispersion of the data, why do we need standard deviation? Anybody? Can I have some input? We already have variance, right? That gives us the idea about how spread the data are. Why do we need standard deviation? Anybody?
Yes. Madam, please continue on that. Madam, are you there?
Yes, I am here.
Okay.
Who will tell me? Hafsa? Can you give some input? Hafsa?
Yes, hello.
Yes. Could you understand my question?
Yeah, why do we need standard deviation?
Yeah, when we already have variance, both almost conveys the same message.
And can we say we need standard deviation because we need to compare the deviation of the data from the mean?
Can you repeat?
We need to compare the deviation of the different data from the mean.
Different data from the mean. That is what we do in variance as well, right?
Yes.
Then why standard deviation? Okay, just
that
think
was my
about it.
Yeah. Okay.
Okay. Everyone just think about it. We'll discuss. Okay, so we have this variance, we have standard deviation. What next? What is the other measure of dispersion that we have? We have variance, we have standard deviation, then we have coefficient of variance, right? Coefficient of variation. Now, what is this coefficient of variation means? It is just a ratio. Coefficient of variance, I think usually represented as CV, or maybe some other symbol. Suppose let us call it CV. It is standard deviation, ratio of standard deviation to the mean. It is this ratio. Coefficient of variation. Now this measure, what will this measure of dispersion do is, it will keep the track of the deviation of data with respect to mean. Means it will give you the idea of where your data is in terms of the dispersion. Variance and standard deviation gives you overall view, right? Some kind
Madam,
of
your sound is very low.
Am I not audible?
Yes, you are audible.
Nanu.
Madam, you are audible. We can continue on that.
Okay, just give me a minute. Just give me a minute. Nanu.
Yes, madam.
Okay, so coming to coefficient of variation, so it is ratio of standard deviation over mean. Standard deviation per mean value, right? Meaning it will give you the idea about the position, about the status of your data in terms of your mean, with respect to mean, where your data actually is. So coefficient of variance, coefficient of variation, then yes, then we have this. Yes, this one. This is one another important measure of dispersion, which we called z-score. And z-score is nothing but it is x minus mu over sigma. Where this mu means mean and sigma is the standard deviation. And x is your data. This is z-score. Instead of calling it measure of dispersion, it actually transforms the data. But it comes under the category of measure of dispersion as well, because it tells you about the spread of data around the mean in terms of deviation, somewhat like coefficient of variation itself, but it will affect, it shows the effect on each and every data, right? It transforms each and every data in the set. X minus mu over sigma. We will see this. X is your original data. And if you use this formula and obtain Z, this process is also called standardization. When you do this, you are actually standardizing your original data. Standardization. This one. So when you actually you can try it out. Consider one data set, a simple data set, find its mean, compute its standard deviation, then try to transform using this formula, z equals x minus mu over sigma. Whatever the new set of data that you will get, calculate mu and sigma for it again. You will see its mu means mean tending towards 0 and standard deviation tending towards 1. When a data have mean 0 and standard deviation of 1, we call it standard data. I mean the data in standard form. Hence, this process is called standardization also. You can keep this term in mind. When we'll deal with modeling, we will look at it again. So this is z-score. Next, come to measures of location. We covered measure of central tendency, measure of dispersion. The third one is measures of location. When we talk of measures of location, so we are actually looking for this 5-number summary of your data. 5-number summary. When we say 5 numbers, those 5 numbers are actually these. Okay, no need to write. Range we can calculate from this only. No? This becomes 5, right? You have mean, max, Q1, Q2, and Q3. So these as a whole is considered to be measure of location, and is